We just constructed an observatory at Harvard University. We are monitoring objects that fly overhead and trying to make sense of them.
This collection of instruments is part of Harvard's Galileo Project.
The Galileo Project is developing several sites that are spread across a geographical region where each site has an array of sensors. Optical cameras, infrared images, there's audio from infrasound to ultrasound, there's radar. It's a wide array of instruments to basically look at the sky all the time to see if you find any anomalies.
Behind the window, there is a camera. They overlap. And so they get a full picture of the entire sky at all times. So far, we have been operating this observatory for several months, and we saw hundreds of thousands of objects in the sky. None of them appears to be anomalous, but even if 1 in a million came from outside of this Earth, that would be big news to humanity and would change our future. And that's what drives my science.
Holding interstellar material. Welcome back to Total Disclosure, the podcast that dares to unravel the universe's deepest mysteries. I'm your host, Ty Roberts, and today we're tackling a question that's haunted humanity for centuries. Are we truly alone out there? Before we blast off, do me a quick favor, hit that subscribe button on YouTube or follow us on your favorite podcast platform. Your reviews and ideas light up my day. So let me know what you think or who you'd like to see on the show next. Want in on the action? Join our exclusive membership for ad-free early episodes, sometimes weeks before they drop, and help keep this cosmic journey alive. You pitch in what you can, and I'll take it from there. Now, let's get to the main event. We're sitting down today with Dr. Avi Loeb, a fearless astrophysicist from Harvard University who's rewriting the rules of the search for life beyond Earth. He's not just a professor. He's the mastermind behind the Galileo Project, a cutting-edge mission to hunt for signs of extraterrestrial technology or non-human technology in our skies and beyond. With a resume boasting black holes, the dawn of the universe, and hundreds of mind-blowing papers, Dr. Avi Loeb has grabbed the world's attention with his book, Extraterrestrial, the first sign of intelligent life beyond Earth. In it, he makes a bold case. We might have already glimpsed alien intelligence, and it's time to stop ignoring the evidence. Today, we're diving deep into his revolutionary idea, the Galileo Project's quest to scan the cosmos for UFOs and interstellar visitors, and what it all means to us and for us if the answer to "Are we alone?" turns out to be a resounding no. So, strap in. This is Total Disclosure, and you're about to embark on a one-on-one journey through the stars with Dr. Avi Loeb that'll leave you questioning everything. Thank you so much, Mr. Avi Loeb. It is an honor to be in your beautiful home today. And I just really want to say from the bottom of my heart, thank you for everything that you've done, not just for, the science community, but for the UFO community and bringing your caliber of scientific rigor to the community. Because,
It's my great pleasure. I mean, I'm driven by curiosity, and this is a subject that is fascinating the public, and we have to address it scientifically.
Absolutely. So today, obviously, we're honored to sit down with Dr. Avi Loeb, a renowned astrophysicist and professor at Harvard University. We're excited to dive into this one-on-one session, and you'll also be speaking at Contact in the Desert come late May.
That's correct.
Awesome. So I just want to start off, Dr. Loeb, with an introduction and background. Your career has taken you from theoretical physics to leading the charge in search for extraterrestrial life. Can you tell us about your background and what sparked this passion for the unknown?
Well, as a kid, I grew up on a farm and was mostly interested in philosophy about the fundamental questions of our existence. And then since I grew up in Israel, there is a mandatory military service, but they allowed me to pursue physics. And that was a good approximation for philosophy. It was useful for the defense of the country. In fact, President Reagan initiated at the time, which was the mid-1980s, the Star Wars initiative. And I proposed a project that was first to be funded by the US as an international project. And that brought me to Washington, D.C. We were funded a few $1 million a year. And in one of my visits, I went to Princeton, where they offered me a 5-year fellowship under the condition that I'll switch to astrophysics. Because before that, I was doing plasma physics, the physics of very hot gases. So I agreed to do that. It was an offer that I couldn't refuse, just like in The Godfather.
Right.
Then after that, I received an offer from Harvard University for a junior faculty position. And 3 years later, to my surprise, I was tenured. And at that point, it became clear to me that even though it was an arranged marriage with astrophysics, it's actually a marriage to my true love, because I can address fundamental questions about our existence in the universe using the scientific method. And so here I am, very different than my colleagues, because I tend to think about the big picture. And the most important question that we have is, are we alone? I mean, we see our house that we live in, and then through the windows, we see other houses very similar to our house on the cosmic street. These are sun-Earth analogs. And we know that there are hundreds of billions of stars like the sun in the Milky Way galaxy, and at least a few % of them have a planet the mass of the Earth, roughly at the same separation. So, you know, there are many houses like our own, and the question is whether they have residents. Right. And that is the most fundamental question, because if they do, you know, there might be a smarter kid on our block that we can learn from. And I'm not surprised that most of my colleagues dismiss that possibility and argue that we're probably alone until we find evidence. You know, it would be an extraordinary claim to imagine something like us. But I think that it's much more likely that we are not alone, and you know, other civilizations existed billions of years ago, because the sun is a late bloomer. It only formed in the last 1/3 of cosmic history, and most of the stars formed billions of years before the sun. And you know, I just remember how my daughters, when they were very young, they used to think that they are the center of the universe. Yes. You know, and at some point they went to the kindergarten and they were shocked to find other kids like them and even smarter. So
different colors and
and different abilities. So I think out of sense of humility, we should assume that there are things like us that existed, and most of the civilizations probably died by now, but we should search for them. You know, new knowledge will not fall into our lap. We should invest time, effort, and money to look for them, and that's what I'm doing.
So, you know, what really brought you on the map, and I don't want to say this like, you know, in a derogatory way, but for the UFO community and the related phenomena, what really brought you to the map was Oumuamua and the interstellar object and what you theorized. Can you explain what you were talking about with Oumuamua and the ridicule of your peers that soon came after?
Yeah, so for the first time, 7 years ago, there was an object discovered from outside the solar system that astronomers recognized in a survey telescope. Before that, we've never seen a big object coming from outside the solar system. And it was found just because it came close to Earth. And that was named Oumuamua because the telescope was in Hawaii, and it means a scout in the Hawaiian language. It was roughly the size of a football field, about 100 meters, and the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And that's a huge change in the surface area of this object projected on the sky. as a result of its spin,
Correct.
And in fact, the most likely shape for the object was inferred to be a flat shape, like a pancake. Yeah, despite what an illustrator made it look like more like a cigar, but that's not true. That's in projection. In fact, it was most likely flat. And moreover, it was pushed away from the sun by some mysterious force without showing any cometary evaporation. It wasn't a comet because we didn't see a tail of gas or dust around it that reflects sunlight. And that's the way you recognize a comet. Now, most recently, and there is a long history of astronomers trying to explain it as a natural object, I suggested that it's pushed just by reflecting sunlight. And in fact, 3 years after Oumuamua was discovered, there was another object that was definitely pushed by reflecting sunlight. And that happened to be a rocket booster from a 1966 launch by NASA. And it was given the name 2020 SO, discovered by the same telescope in Hawaii. It was not discussed much because people realized it's actually technologically manufactured by us. And in fact, just recently, on January 2nd, 2025, there was a point source of light near Earth that was recognized by an amateur astronomer as a new near-Earth object, new asteroid. And so the Minor Planet Center, the official center for documenting near-Earth objects, gave it a name. And then 17 hours later, astronomers said, wait a minute, this orbit of this new asteroid matches that of the Tesla Roadster car that Elon Musk launched.
Oh my God!
In 2018 with as a dummy payload on the Falcon Heavy. It was his own car, and it's now in orbit around the sun. And just last week, I submitted a paper saying that you have to be careful when you call something a comet, because there was a paper 3 months ago published in the Proceedings of the National Academy of Sciences that claimed here are 14 objects that do not show any cometary tail. So, and nevertheless, they have some additional force acting on them in addition to the force of gravity. And they said, well, these are comets, but their tail is not visible. So they call them dark comets. And the acceleration that they exhibit is really small relative to the gravitational acceleration. And I looked at them and I asked my postdoc to check when each of these objects was closest to Earth. And then I went back and looked online for whether there were any spacecraft launched. So one of them, for example, came closest to Earth around November 1965. And I checked which spacecraft were launched at that time. Turns out that the Soviet Union launched a spacecraft named Venera 2 towards Venus. And I look at the orbital parameters and I see that this object that was classified as a dark comet actually went straight to Venus after being close to Earth. And it matched, roughly speaking, the orbital parameters, and the acceleration, in addition to the force of gravity that it exhibited, was just as a result of reflecting sunlight. And so I wrote a paper just a few days ago saying that. And my point is that you have to be careful not to call animals that, suppose you want to identify all animals as zebras, and then you see an elephant, you shouldn't call an elephant a zebra without stripes.
Right.
And for the same reason, you shouldn't call a spacecraft a dark comet. And that is the tendency of people to just, for scientists to feel comfortable with objects that they cannot explain. And they were arguing that perhaps Oumuamua was a dark comet. And I said, you have to be careful about that because we haven't seen a cometary tail. It's just like Hans Christian Andersen's tale about the boy that was looking and saying the emperor has no claws. In this case, the object doesn't have a cometary tail. That's what I was saying. But they said, no, it's invisible. The emperor has claws, you just can't see them.
So it's for me, the science community is, like, wouldn't this excite the community? Wouldn't people rally around the idea that this could be possibly something, why are they so quick to, we can't explain it. We're just going to slap the name dark on it. So dark matter, dark comet,
Yeah.
it just,
It puts the mind of scientists at ease that it's really not anomalous because you call it a comet with an additional adjective, so it feels as something that is familiar. I mean, other explanations were maybe it's a hydrogen iceberg. We've
Yes.
never seen that before, or nitrogen iceberg, or perhaps a dust bunny, all kinds of ideas that were never related to any object we saw, and we're trying to explain the anomalous properties of this object. And I'm saying, okay, well, you're allowed to think whatever you want, but let's leave on the table the possibility that it's artificial because it behaves in ways that are different than the rocks we have seen in the solar system.
Absolutely.
And the issue is really, if you brush it under the carpet, then you are not curious enough to explore that possibility about other objects. So just a month ago, after finding this Venera 2 spacecraft, I realized that there is a whole population of objects that are called empty trash bag objects. These are objects that are being pushed around by radiation from the sun. And
like a light sail?
Well, so the belief is that all of them are just broken pieces of satellites or in the vicinity of Earth. I mean, they're too small for us to see at a large distance, so we see them only around the Earth. And indeed, there could be objects that were just broken pieces of satellites. But one should be open-minded, because I found one object that was doing zigzag motion, and I thought, well, that's the definition of an unidentified anomalous phenomena. But so you say, nobody in the scientific community is looking into UAPs, but when they find a UAP, and they call it an empty trash bag object and do not look into it, do not try to model it. And I'm saying, we should look at all anomalies because they would signify perhaps something that we've never seen before that can teach us. And not all the technological debris that we find in our vicinity were launched by the Soviet Union or by NASA or by anyone else on Earth. Some space trash may have originated from another star. Why should we assume that Elon Musk was the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago? There could be a lot of cars, just like the Tesla Roadster car, floating in interstellar space. And by the way, when a star like the sun ends its life, it will end its life. The sun will die in 7.6 billion years. It will expand, and there will be a very significant wind coming out of it. And that could sweep all the technological debris that we have around Earth right now into interstellar space. Even if we don't launch it, eventually it may end up there because the sun will brighten before it ends its life.
Exploding, sending everything outward.
Yeah, sending its envelope outwards. So there could be a lot among the rocks, and I don't deny that there should be a lot of rocks in interstellar space. There could also be some technological objects. And they would fall into two types. One is space trash. These are pieces of broken structures.
Rocketry.
Or even like Voyager, because Voyager is now losing its ability to communicate with Earth. And, it will exit the solar system in 10,000 years, and it will be just a piece of junk at that point. So you could have a lot of devices that are not operating, that are billions of years old, floating through space. But you could also have things that are operational, and those could be close to Earth, monitoring what happens here. And we should be open-minded and just search the sky without any prejudice.
And I could not have said that better. So, many people are familiar with SETI's, or the search for extraterrestrial life, their approach to listening for radio signals. You're the head of the Galileo Project. How does the Galileo Project carve its own path in the search for intelligence, and what makes it focus so groundbreaking in its approach?
So SETI, for about 70 years, have been searching for radio signals. And that's just like waiting for a phone call at home. Nobody may call you when you're waiting. And even if you do it for 70 years, the age of the universe is 13.8 billion years. And why would they specifically call you when you're listening? They may have called us 1,000,000 years ago. We were not listening back then, and the signal is now 1,000,000 light years away. And therefore, one thing that Albert Einstein said is, it's not smart to keep doing the same thing over and over again and expect different results.
Yes.
Now, of
Definition
course,
of insanity, right?
yeah, and we can continue to do that. There are lots of stars that we can monitor for radio signals. But another approach is to search for a tennis ball in your backyard or an object that came from a neighbor's yard. And this is something that we only started doing over the past decade when astronomers found the first interstellar object, Oumuamua.
Mm-hmm.
And then after that, together with my student, we discovered a meteor, an object that was 0.5 meter in size that collided with Earth in 2014.
Correct.
And then I decided to lead an expedition to the Pacific Ocean to search for the materials from this object. And we did retrieve from the impact site, we retrieved some tiny molten droplets that we analyzed in the laboratory of my colleague here at Harvard, Stein Jacobson, and we found some materials that are not represented in the solar system, that have a composition of elements, chemical composition that includes a very high abundance of beryllium, lanthanum, uranium, at up to 1,000 times more than you find in the materials that made the solar system. So,
really?
Yeah, so we don't know where this material came from, and it's possible that it came from some natural source, natural origin. The goal is to go again for another expedition where we can retrieve bigger pieces of the original object. That would require placing a robot on the ocean floor, which is about 1 mile deep at that location. Wow. So that we can pick up bigger pieces. And
right.
That expedition will cost more than the previous one, which was $1.5 million in cost. Ooh. The new one would be probably $6.5 million, and we are currently in the process of seeking funding. Right. Yeah, so that's one branch of the Galileo Project. And then another branch is to look at the sky, and following all the reports from the Director of National Intelligence that there are unidentified anomalous phenomena in the sky that military personnel report about. And there were congressional hearings. There is also the All Domain Anomaly Resolution Office in the Pentagon. And so we are just doing the scientific study of whether there are any unusual objects in the sky. We built one observatory at Harvard University, which is collecting data on about 100,000 objects every month. And we published a paper that analyzed the first 500,000 objects that we analyzed with machine learning software. We're trying to find out if there is anything unfamiliar among these objects, right. Something that doesn't look like a bird, a plane,
Superman, yeah.
Right. Yeah. Yeah, if it looks like a Superman, that would be really amazing.
That would be great, yeah.
Yeah, but the goal is to also have multiple units of the observatory looking at the same object so we can figure out the distance. That's called the triangulation.
Like an array of multiple observatories.
2 or 3 of them. We are now in the process of building that at Harvard, but I also received funding recently for another observatory in Pennsylvania, another in Nevada, and finally one in Indiana. So it's altogether over the past couple of months, I received about $5 million in funding committed. We still need to build those things, and hopefully by the end of summer 2025, we'll have 2 additional observatories working, and they will provide us with millions of objects in the sky every year. And we will try to assess whether any of them is unusual and not from this Earth.
Can I ask you, now, this is going to involve a little bit of speculation. Say the Galileo Project analyzes something and you really don't know what it is. What would be the process that is initiated, and would you tell the public?
Right. So we will approach it the same way that any astronomical observations follow, which is to first look at the data, make sure that it's not an artifact of the instruments,
Right.
Make sure that we can trust the data, and then if it looks really anomalous in the sense that something is moving in the sky faster than any human-made technology is, then we would write a scientific paper just on this object. That's what I tell my team, that people should not be too excited if we just write about millions of objects.
Right.
If they see a paper about one object, they should be excited, because then it means that we did find something.
Okay.
And of course, the data will be public because the sky is not classified. The difference is most astronomers are looking at objects that are very far away, and they focus on a small part of the sky. We had to build an observatory from scratch that looks at the entire sky all the times, and also does it in the infrared, optical, radio, and audio. Something like that was never built before, but now we know how to make it, so we can make multiple observatories of this type.
Amazing, amazing. So when we talk about intelligence beyond Earth, it's a concept that's kind of hard to pin down. How do you define in your work, and what specific clues, like artificial structures or signals, are you hoping to uncover?
So I'm just seeking something that is not familiar. In other words, I don't want to imagine what it may be like. I would be really surprised if it has some pilots that are biological. I would expect it to, if it's functional, to have artificial intelligence that operates it. But I don't want to imagine, because when we go on a date, we can imagine what the partner might look like.
Right.
But that's because they share the same DNA as we do. But when you meet something from another star, all bets are off. And it could be well beyond our imagination, which is shaped by our past experience. So even science fiction writers, they cannot imagine the unknown. They can just think about what they experience and try to expand that a bit.
Right.
But I prefer to learn from nature. In other words, whatever nature brings to our front door, we should examine and try to figure it out. And that's why, people ask me, how should we respond if there is a visitor in our backyard? And my answer is that we should not appoint committees that try to envision or imagine what it might be like to meet a visitor, because the visitor would look probably very different than we imagine. So let's wait. When the visitor arrives, we'll collect as much data as possible, try to figure out the intent of the visitor, what brought the visitor in, and only then respond to it. And one example that I like to mention in this context is one day my wife noticed someone standing on the street looking at our house for an hour. And she said, I'm really worried about that person, because maybe it's one of your fans, and I'm not sure why that person is looking.
It's just creepy, yeah.
Yeah. So I said, no worries, I'll go and speak with that person. And I went to him and said, why are you staring at our house for an hour? And he said, well, I used to live in this house 50 years ago as a kid. And I said, in that case, why don't you come with me? I'll show you the backyard and so forth. And then he pointed to a place where he said that, 50 years ago, he buried a cat named Tiger there. And I said, yeah, the name looks familiar, because actually saw the name Tiger on a tombstone there. And I thought maybe there is a tiger buried under. And so the lesson from this is that, a visitor could have much longer history with the place that we are currently inhabiting, and we can learn much more from the visit. But in order to figure out the intent of the visitor, we really need to watch it and learn more about it.
And not make maybe snap judgments.
Exactly.
Right? Ask the probing questions, find exactly a data-driven approach.
Well, in fact, there is a new movie that just came out, Mickey 17, and it's all about the way that humans interpret, sort of, in that case, alien life in a way that is inappropriate, given that that alien life might be even smarter than humans. And we will be shocked to meet artificial intelligence that supersedes our own intelligence. Probably within the coming years, we will have the ability to interact with such AI systems, and that would be a preparation for us meeting alien intelligence in a way, because artificial intelligence is related to chips, is enabled by chips that are made of silicon and are very different than flesh and blood. The way our brain operates, our brain uses about 20 watts of power, whereas these systems, AI systems, use gigawatts of power. And they're clearly a very different beast than our brain. We are training them on human content, so when they give us answers, it sounds familiar, but the way they think is quite different. And when we try to consider them as imitators of human intelligence, it's just like trying to put lipstick on a pig. It will not make the pig human. And so I think it will be the first experience of us encountering alien intelligence, but the surprise will really come from another star, because they may have had billions of years or millions of years of technology. We just had 100 years since quantum mechanics was discovered, and that's when the physics that we are currently using to make those silicon chips were understood. We would not be able to make artificial intelligence systems now unless we had 100 years ago the discovery of the principles of quantum mechanics. Just think about how much more we will know in 1,000,000 years from now.
Right. And exponential growth factoring in, just in the past 100, we went from horse and buggies in that same 100 years, we're landing on the moon. Right. So
in fact, the question is how to save humanity from a single point catastrophe. So Earth might go through a catastrophe, either because of self-inflicted wounds that we create as a result of climate change or nuclear war or biological war, but also it could be a natural phenomenon like a big asteroid colliding with Earth, or the sun erupting in a way that we've never experienced. And so it's clear that it would make sense for us to go to space. And in fact, Elon Musk is advocating going to Mars. I'm not sure that's a good idea. It's just another rock, not very far away, doesn't have an atmosphere. It's actually more dangerous to live on the surface of Mars. It would make sense to design a space habitat, some platform similar to a space station, which can maneuver and go places. Okay. And that is just like Noah's Ark, when Noah tried to prevent catastrophe, so that the Great Flood was threatening many lives. So he put in an ark the forms of life that he wanted to preserve, and we can do the same with a space station platform that goes to space. And I think it would make a lot of sense to try that. But we could also send ambassadors of humanity in the form of AI systems that would keep the torch of what we care about alive into the distant future, because they will not be bored in very long journeys through interstellar space. And eventually, when they reach some destinations, they could serve as gardeners. They would seed other locations, other planets, with the kind of things that we want them to recreate there. And so there are two ways for us to maintain longevity. One is to lift some people out of this Earth. Another one is to send AI systems. And maybe other civilizations did that already. And we could be inspired by meeting their products.
Right. And this is going to be going down an avenue, but a lot of people, I'm sure you have heard of the Greys, right? The little gray aliens, the archetypal alien.
No.
So the archetypal alien, the gray guy with the big eyes and big head, right?
Oh, yeah.
A lot of people have speculated that maybe there's some sort of advanced form of artificial intelligence meets biological advancement, right? It's not alive, but it's not alive.
I see.
Right? And it's an ambassador from a different universe, right?
And
because
it could
again,
represent our future. That's what you're saying.
Absolutely.
Yeah.
Right? Because we, as creatures, as biological creatures, again, we're subject to boredom. We need to eat, sleep, whereas these don't, and they can travel for thousands of years with the objective of getting to where they're going.
Yeah, with an advanced enough technology, there may be a way to extend the lifespan of humans indefinitely, in principle. Just like a car, you can repair it again and again. And that could happen, especially thanks to AI right now. Now, AI could integrate itself into our brain because we would be hooked to information coming from AI systems. And so I think it's inevitable, even if you don't put electrodes in our brain, the interaction with AI will change the way humans think. Not necessarily for the better, because right now we have to think about solving problems or getting information that would help us. But AI could feed us with that information, and we wouldn't need to think too much. At the risk of the AI using us as tools, that is the issue.
Right. So, I mean, obviously, such a discovery, if it were made, could ripple through every facet and part of society. How do you envision it reshaping religion, culture, or even our sense of identity as a species?
I think it would make the biggest change ever that humanity went through. So if you think about the early humans, started millions of years ago, they were in Africa, and if you had to find them, you would find them in jungles, on trees, and so forth, because they came from the same ancestry as the chimpanzees, for example. And eventually, right now, what you find is humans in high rises, in cities. And I would argue that going from a jungle to a high rise is actually more of a leap than going from a high rise to space. So eventually, I think we will make that second phase where we go from Earth to space this way. But we can, in fact, be inspired in terms of recognizing the potential of interstellar travel by meeting whatever aliens sent our way. And because they may represent our technological future, and we can get a shortcut into viewing that future. Now, this is just in terms of science and technology. We might realize new technologies we haven't yet imagined. We might figure out there's something about science that we don't know right now. For example, we don't know how to unify quantum mechanics and gravity, and maybe they are using it for propulsion. We don't understand what really happened before the Big Bang. And maybe they have a theory of quantum gravity that allows them, in principle, to create a baby universe. Just think about that. It's just like making a cake. In order to make a cake, you need to know the ingredients that are necessary and how to put them together, and then apply heat. And once you have the recipe, the only thing you need is an oven that would allow you to create those conditions and make a cake. Now, if those aliens are able to understand the recipe for a baby universe, what happened before the Big Bang, they can, in principle, be regarded as playing the role of God. They can apply to the job of God, because the basic requirement is you should be able to create a universe. What I'm saying is that a very advanced level of science could provide an approximation to what we associate with God in religious texts. And in fact, if you just think about Moses, in the Old Testament, there was this burning bush that was never consumed that convinced Moses, that miracle, that God exists, that there is a superhuman entity. And if you were to show Moses a cell phone today, he would be even more impressed than with a burning bush, right? And And of course, this is not superhuman because we are descendants of those early humans, and it's just that we have better technologies. And what I'm trying to say is that for us, it might look like miracles. I mean, some of the things we encounter, but in fact, they represent a higher level of science and technology. And this is a way of bringing together religion and science, because perhaps all these stories and myths about a superhuman entity is all about a very advanced scientist in a white lab coat that created things that we regard as miracles.
And you literally, you said exactly what I was thinking. And for me, I think the problem with scientists or science, maybe the science community, is with religion, they tend to throw the baby out with the bathwater, right? They separate themselves, when I think there's an approach that if you come together, right? And there's another way forward. I don't know really.
I mean, that's the other important significance of an encounter with some aliens. Because we are, if you look at the news every day, we are focused on conflicts, often about territories or about status, and so we tend to look down, and we spend $2.4 trillion every year on military budgets, 1/3 of that in the US.
Yep.
It's a huge amount of money. I calculated if we use this money for space exploration, we can send a CubeSat towards every star in the Milky Way galaxy within this century, if we just use the same amount of money. But instead, we are trying to either kill others or prevent others from killing us.
Right.
And I don't think that the solution will come, from people singing John Lennon's song, "Imagine all the people living in peace." I think it will come through shock therapy, where we would realize that there is a better way. And that is looking up, not looking down, looking up, and realizing that there is a smarter kid on our block that actually managed to achieve much more. And that will change our focus. And once we realize there is someone else, on the cosmic street, there is another house that has residents, then we would feel as if we are part of the same team, because we are all in the same boat, the Earth, sailing through space, and we better, work together rather than fight each other. I had this sense of teamwork when I was on the ship during the expedition to the Pacific Ocean. All the members of the team were helping each other for the success of the mission. And that was a very good metaphor for how humanity should work. But instead, what you find is, even within the US, just one nation, you have this polarization where you have two camps clashing, rather than everyone working together.
For the benefit
of the nation in this case. Yeah.
Right. And
by the way, it wasn't that way. If you look back closer to the Second World War, I mean, there was a sense of a community that everyone should contribute to. And back then, there was appreciation of science as well, because the Manhattan Project had political implications. It ended the war, and right now, science is not appreciated as much.
Right.
It was funded for a while because of the Manhattan Project. And one event that made me wonder whether something like that could have brought science back to the focus of society is there was an asteroid recently that had a 3% chance of colliding with Earth. And NASA mentioned it, and then they realized by better measurements of the trajectory of this object that it will not collide with Earth, probably.
I think, if I'm not mistaken, this is asteroid 2024, YR4.
Exactly.
And so, again, 3%. I mean, that's a lot.
It was at the peak 3%, but now it's down to a few times 10 to the minus 5. So
correct.
It's really negligible. Maybe it will hit the moon. There is still a 1% chance. But the point is, I was a bit disappointed that it's not a threat, actually, as much as it sounds paradoxical. And the reason is that suppose the likelihood for a collision with Earth would have risen to 100%, okay? Then immediately we would calculate where it may hit on Earth, and real estate value would go down in those locations, all these.
Oh, yeah.
And people would migrate away from there. So it would become a big international issue. And then scientists, astronomers would have the highest status in society because they could inform us about the whereabouts of this object and about the ways of deflecting it. And young adults would be attracted to science because they can contribute to humanity. And so that would have elevated science to the forefront. And there was a society where astronomers were at the highest societal status, and that was the Mayan culture.
In culture, yes.
Because they believed that the positions of the planets or the stars are correlated with the success, let's say, of a war. And so the politicians of the day said they want to have astronomers, priests, that advise them when to go to war based on the location of Mars and various other stars. And so that was a period of time where they collected huge amount of data on the sky, and astronomers were highly regarded in society. I think we should go back to that situation. And one way to bring astronomers to a high societal status is by discovering a threat or something from the sky that affects all humans on Earth, and it will bring people together. So, of course, you can think about a big rock that may hit the Earth, just like in the case of the dinosaurs. They were not smart enough to look up, and they died. But we are smart enough to perhaps notice it in advance and do something about it. But it could also involve finding a neighbor, something that is not just a rock, but actually a device manufactured by an alien technological civilization.
Right. And that's really an amazing, it's an amazing way to, like you said, it would take the conversation rather from Americans and Russians, and it would be Earth.
Right.
We need to protect Earth. And, now that you say it, and while you were talking, I was kind of thinking to myself, that's kind of what I really love about the UFO community in itself, is because when we're talking about UFOs and potential life beyond Earth, what we're doing is we're bringing everyone on Earth to a level playing field, like you had mentioned, right? We're all one. There's no more nationalism or racism. We're talking about Earth as Earthlings. Right.
And in fact, President Reagan mentioned that in his speech in the United Nations.
Correct.
And I think it's often forgotten. And even when we notice anomalous things in the sky, then astronomers, my colleagues, immediately classify them as rocks of a type, even if it's rocks of a type that we've never seen before. And my point is we should be open-minded, and in fact, we should invest resources in doing the search. So after the last elections, Peter Thiel appeared on a podcast, and he said, you should never bet against Elon Musk because he's right. And a day later, I placed a public bet against Elon Musk.
Oh, yeah?
And I posted it on medium.com, where I post my essays every couple of days. And the idea was that Elon argued that we have responsibility for our cosmic future.
Correct.
And therefore, we should go to Mars because we are probably, he said, alone. And I argued, no, I don't think that we are probably alone. I think it's the other way around, because there are hundreds of billions of stars like the sun, with planets like the Earth, maybe a few percent of them or more. And moreover, the sun came late to the scene, and those civilizations may have preceded, been around billions of years before us. And it takes Voyager just 1 billion years to go from the solar system to the opposite side of the Milky Way galaxy.
Mm-hmm.
So they had plenty of time to reach us. And I'm willing to put 1% of my net worth against 1% of Elon Musk's net worth. And that would make the sum of the two 4 billions, thanks to him primarily. And we will use this money to search for the next decade for any technological debris that came from another civilization near Earth. And I actually came up with a concept for a space telescope that can do that by looking even from objects that are 10 meters in size, 10 times smaller than Oumuamua was. we could detect them if they come closer to the sun. Within the orbit of Mercury, they are close enough to the lamppost for us to see.
Yes.
So I said, if within 10 years we don't see such technological objects, I'm willing to give Elon another 1% of my net worth. But to get it started, we really need billions of dollars before we can claim that we don't find anything, right? So the point is that for other scientific projects, we invest funds at that level. For example, we invested $10 billion in the Large Hadron Collider to discover the Higgs boson. We haven't found supersymmetry. And we invested $10 billion in the Webb telescope to find the first stars and galaxies. That's a subject that I pioneered about 30 years ago.
Amazing.
And we should invest a similar amount of money on a question that is far more exciting to the public. Right now, there are plans to invest in searches that are not as exciting to the public, like the nature of dark matter or other questions. And I argue that we should listen to the public, and we have the tools to conduct the search, given that over the past decade we found the first interstellar objects, that some of them look anomalous, implies that we should trace all the interstellar objects near the sun. There are right now of the order of 1 million objects within the orbit of the Earth around the sun that are roughly the size of a person. That they're a huge number, and we just cannot see them because our existing survey telescopes cannot detect the amount of light reflected from it by given their size. But if we build special purpose telescopes, we can look for them. And of course, every now and then, one of them collides with Earth and appears as a meteor. But that's very rare because the cross-sectional area of the Earth as it orbits the sun is very small.
So it's and I think that's one part of scientists' job, is to get the public excited. So it's not just enough to say we want to do this. It's you need to get the public involved. You need to get them excited. We look at the early space race, right? It was a competition. Everyone was involved and wanted us to be the first, right? So, with Oumuamua, I think you did that. You excited people, and people wanted to figure it out. But we only had a certain time frame because it was
limited, and we didn't get as much information as needed. By the way, the thing that would make me happy is getting as much data as possible, because once we have a flood of data, there wouldn't be a way for my colleagues to argue, it's a rock of a type that we've never seen, because it will be clear if it is a technological gadget, it would be very different than any rock. So all we need is very high quality data. And my hope is if we get funded to the next expedition, we might find, in the wreckage of that meteor, perhaps there would be some kind of a technological object, maybe with buttons. And the question is, should we press a button? But if we image the sky for long enough, we might see something unusual near Earth. Or there will be the Rubin Observatory in Chile that will start operations this year and will monitor the entire southern sky every 4 days with a camera that is unprecedented with 3.2 gigapixels. And so that could discover UAP, and it could discover Oumuamua-like objects every few months. And so my hope is in 2025 that we'll have exciting results coming out.
Right. And so pardon me if maybe this doesn't sound as scientific as maybe you would say it, but it's my understanding that when we go and we look at early solar systems and star systems, we expect them to be a certain way, but we're finding the opposite, that they're more
So right now, first you have the techniques that we are using are selecting systems that are not necessarily the same as the solar system. And in 1952 there was an astronomer named Otto Struve who said, imagine having a star with a Jupiter-like planet very close to it. This is called a hot Jupiter that is getting hot by the illumination from the star. And he said, if that happens in nature, we could find such systems because this very massive planet, Jupiter-like planet, would tug the star back and forth so we can see that it's moving. But also, if it comes in front of the star, it will block a significant fraction of the light. Because Jupiter is 10 times smaller in size than the sun, but so it blocks at least 1% of the light from the star. But then for about 40 years, people ignored that suggestion. They said, we understand why Jupiter is so far from the sun. It formed in a region where ice, water ice could form, and there is no reason to suspect that Jupiters may exist close to their host star.
Right.
And then, so time allocation committees on telescopes did not allocate observing time to look for such systems, even though they were detectable, until in 1995, there was such an observation that discovered
40 years later.
Yeah, more than 40 years. And of course, it received the Nobel Prize for the first discovery of a planet close to a sun-like star.
Right.
But I looked at their paper from 1995, and there was no reference to the paper by Otto Struve in that paper. So what does it tell you about the way science is done? That very often scientists do have a set of priors. They assume something about what they might discover, and they're not taking any risks.
Right.
Why waste time and look for hot Jupiters when we don't think that they exist? I mean, you might argue, okay, well, put 10% of your observing time and search for this. I mean, you wouldn't lose too much. No, but it was zero until 40 years later. And then once it's found, then whoever proposed this method is forgotten. You know, So science is not very efficient because there is a lot of resistance to taking risks. And the whole idea of tenure in academia was invented to allow people with job security so they can come up with new ideas and go against the mainstream. But it's not being practiced because people just want to amplify their status by getting honors, awards, and also getting money for their students and postdocs by committees which are dominated by people who don't take risks, that are thinking alike. And so as a result of that, you don't see much innovation as much as you might want to have. And there is often a lot of resistance to anyone that deviates from the beaten path. So if there was an object that is anomalous, like Oumuamua, and I try to say, let's open the possibilities, because right now we don't understand it as a rock that we have seen before, then people resist and invent rocks that we have never seen before as the doctrine, or dark comets.
Dark comet.
Just not to discuss the other possibility. And I say, let's collect as much data as possible before we converge on anything. But in order to be curious, in order to seek the data, you have to allow yourself to find something new. Yes. If you don't allow yourself to find something new, you will be in the same situation as when Otto Struve suggested looking for hot Jupiters. Nobody would believe you. And then for 40 years, nothing will happen. Now, there might be a miracle 40 years later, and someone would just try it and then find it. So things like that can happen, but the time delay is so significant that, you know, it would be more than a generation before we know the answer.
Right. Now think if we had found that planet when proposed.
Yes.
Right? How far along we'd be
exactly.
now. So,
exactly. And
again,
think about Galileo. He was put in house arrest.
For merely...
looking at the 4 moons of Jupiter. And by the way, a few weeks ago, I received a donation from the most accomplished sculptor in the US called Greg Wyatt. He created sculptures that are in New York City, Washington, in Arlington Cemetery. And he created one of Galileo looking at the 4 moons of Jupiter and gave it to me as in recognition of the Galileo Project. So it's now in my office. And he also made watercolors that he's sending my way that I will put there. And so Galileo suggested that the fact that you have moons around Jupiter imply that we are not at the center of the universe. They are not circling us, they are circling Jupiter. And he was put in house arrest because he wouldn't comply with the doctrine at the time that the Vatican publicized. Yes. And in 1992, the Vatican admitted that Galileo was right. And that was 2 decades after humans landed on the moon. I mean, so
Wow.
eventually they admitted that they were wrong, but that was like 350 years after Galileo was died. Yeah.
Yes.
And so the point is that the process is very inefficient because people just don't want to deviate from their belief system. And the best way not to deviate from a belief system is not to take new data, not to seek new knowledge. Basically, if you say, I don't want to look for hot Jupiters, you will never find them. And then the fact that they don't exist would be supported by the fact that you don't have any data on such an object. And then you can argue that it's even an extraordinary claim to say that there are hot Jupiters. And it requires extraordinary evidence, but if you don't seek it, you will never find it.
Exactly.
So that's a circular argument that is often made in the context of looking for technological debris or objects near Earth from another civilization. It's not an extraordinary claim to think that there are things like us near other stars. That's not extraordinary at all. In fact, to me, it sounds like common sense, like the most ordinary thing to think about.
Right.
And ordinary claims require ordinary evidence. You just need to invest the time to look for the evidence.
Said evidence.
Yeah,
right.
Exactly.
So with that being said, looking ahead, what is on the horizon for the Galileo Project? What breakthroughs or milestones do you hope to see in the next few years that could bring us closer to these answers?
We just need as much data as possible about the objects that surround the Earth or within the Earth's orbit around the sun. And so the Galileo Project observatories, there will be 3 of them operating by the end of summer 2025. And hopefully within a year, we will have millions of objects that we monitor, and perhaps 1 out of a million will be extraterrestrial. And the point is the US government is focused on national defense, and obviously they are happy if they identify maybe 97% of the objects, but that's not good enough for a scientific search, because even if 1 in a million is from outside the Earth, that would be huge news.
The implications, in all, like I said, all it takes is 1.
Exactly.
And the implications are tremendous.
Exactly. And moreover, it's my day job to find objects from outside the solar system. It's not the government's job.
Mm-hmm.
And if they are puzzled by something they cannot understand, they would prefer to keep it under wraps, because suppose it's made by an adversarial nation, they don't want to show the weakness of their intelligence. And so they would prefer nobody to know about it. They would prefer not to release it to the public or to scientists. But
hinders that hinders science, and just by nature.
It does, because I think that any information about the universe at large, especially our cosmic neighborhood, whether we have neighbors or not, that should never be hidden from the public's eyes. I mean, everyone should know about it. It may be shocking, but at the same time, it's just like, suppose you live with your family at home and you don't know whether you have neighbors, but then you go out one evening and you find a tennis ball that was thrown by a neighbor. Then you have the dilemma of whether to bring it up during dinner with your family members. And you might think that it's better for the family member to sleep well and be at peace, not to know about it. But my advice is to let them know about it, because one day the neighbor may show up in your front door or backyard, or may affect your life in a way that is significant, and your family needs to know about it.
Might I say that you are very good at painting a picture, like using real world examples. This is just off key, but you're very good at that.
It's because I explain only things that I fully understand, and I don't think very differently than a common person. I ended up as a scientist by chance, by coincidence, as a result of circumstances. But the way I think is trying to use common sense. But what surprises me is not that. It's the fact that some scientists regard it as controversial, which to me implies that common sense is controversial sometimes in academia, which is really strange.
Notion.
Yeah.
What a notion. And for those of us who are inspired by this quest, not just maybe the search for life, but what you're doing specifically. How can the public join in, and what role could everyday people play in supporting the Galileo's project mission?
Right. So one thing I hope to do is one of the observatories will provide data that can be viewed by the public in real time, so that we could get reports. If our machine learning, artificial intelligence software is unable to recognize something quickly, but the public notices something, we can look into that. And whoever identifies that kind of a thing would be recognized in the paper that we write about it, if it ends up being an interesting object. So that will hopefully happen with one of the observatories that we will build. There is another one that is planned for a STEM education center that will be built in the future, and I hope there to train students and young people to be excited about science, discovering something new. In terms of public helping the mission of the Galileo Project, I think funding is really essential.
That's what I was going to say.
For example, in order for us to use a robot and go to the expedition to the Pacific Ocean again to find bigger pieces of the original meteor from interstellar space, we really need the $6.5 million. And if there is a way for the public to provide that, we will fulfill our mission and report back whatever we find. If a single donor gives us that, the donor is most welcome to be on the ship and see what we find. I mean, to be part of the team. This is one example of making something really happen. And I hope we also have another meteor that we identified from interstellar space, and that could be the next expedition after that one. And as far as the Galileo observatories are concerned, we are able to build observatories if we have proper funding for that. So that's another opportunity for helping us. And as of now, we are mostly missing scientists that can be engaged in the data analysis. And for me to hire people, I need to have the funding to do so. And for the hardware, we received enough funding to build these 3 additional observatories to the one we have, but we still need people that will be able to analyze the data. And for that, I really need the financial donations in addition to what we have right now.
Absolutely. So I want to end with a bit of wonder. So if you had the chance to ask an extraterrestrial civilization one question, what would it be?
What happened before the Big Bang?
Ooh.
And the reason is, first, it represents our cosmic roots. If we want to understand it, it's the first chapter of Genesis in the Old Testament, in the
God
Bible.
said, let there be light.
Yeah.
Yes.
But obviously there would be a different version there, because they probably, if they are very advanced, they would know the details. And by the way, the breaking news is that the universe was not created in 6 days. It took 13.8 billion years. And God did not rest after the 6 days, because we would find evidence. If God rested, we would see a special pattern in the cosmic microwave background, brightness fluctuations. We don't see that. 6 days after the Big Bang, there was nothing unusual according to the data that we have as of now. So clearly, the story that was written thousands of years ago, or was delivered thousands of years ago, is not accurate in the details. But it had one insight, which is that everything started at one point in time, the Big Bang, which is what the modern scientific version says. But the aliens may know much more about it. And I would like to understand, because it will also suggest how to unify quantum mechanics and gravity. And that's something we don't have. And perhaps if we had that knowledge, we could have designed new ways of moving from one point to another. For example, people talk about wormholes or about warp drives or anti-gravity propulsion. All of these concepts require new physics beyond the current understanding of gravity and quantum mechanics. We need something that unifies them in a way that perhaps can be engineered. And if they tell me what happened before the Big Bang, I could reconstruct the theory of gravity that may do that.
Wow. Thank you. And I really do want to say thank you for sitting down with me today. Contact in the Desert. What are your plans for like what you'll be presenting?
I will discuss the latest findings of the Galileo Project and the plans that we have for the coming year, making 2025 a very exciting year.
Right. From everything that you've said, it sounds like 2025 is going to really be, let's say, the year of the Galileo Project and things coming together. So I just want to say thank you again for doing this. And it was truly a pleasure to sit with you today. You know, as a boy, did you ever think that you'd be doing this?
No.
Because,
but in a way, I haven't changed in my in the way I look at the world. You know, as a kid, I was full of wonder. I was curious. I wasn't afraid to ask questions, and I remained the same way. I refuse to surrender. What I often say to young adults is, never pretend to be the adult in the room. Maintain your childhood curiosity, because at the dinner table when I was a kid, I remember asking a question and then the adults in the room would dismiss it or say something that didn't make sense. And I thought that by becoming a scientist, I could answer the question myself. And that applies also to the UAP subject. Rather than listening to all the noise that you hear around it, let's just figure it out.
Right. That's a wonderful, great note to end on. Thank you, Dr. Loeb, for your time today. And I really can't wait to see what you have in store for Contact in the Desert. I'll be there. I'm probably going to interview you right off the stage. I think that's what they have me set up doing. So here's to the next time.